Thursday next week?
So we're going to do 2.1 now. I think it will be due on Thursday because I finished 2.1 with my previous class. Obviously, we spent some time talking about this stuff, but yeah, I forgot to do it with my first class, or else I would have. Yes.
Word.
No, it's in Excel.
You know
What?
She's like word, like okay, word.
Oh.
I don't know why it's so funny.
Because it's so nerdy, that's why it's so funny. All right. So chapter 2 is set theory. So first we're going to do 2.1, which is the language of sets. So we're going to do a lot of definitions and some examples. So let's talk about familiar sets. So familiar sets of numbers, we did a lot of this before with the familiar sets of numbers. So one, a familiar set should be the natural numbers. Oh my gosh, what are the natural numbers?
Counting numbers.
The counting numbers, good. So what are those? 1, 2, 3, 4, 5, 6, 7. So usually in math we do a fancy n. It's the set. We begin and end with the squiggle. 1, 2, 3, 4, ... All right, so let's point out the important stuff. This capital N is the name of the set. It's usually a capital letter. Here, because we're talking about the natural set numbers, which we already know, it does have a specific letter assigned to it. Okay? What else is important about this set notation? The squiggly brackets. We're going to begin and end with the squiggle brackets. And we read that as the set. Another important part is that each element in the set is separated by commas. Each element, like 1 is an element of this set. It's a member of the set. So each element or member of the set is separated by commas. Separated by a comma. What about this ... What does ... mean? It continues like this forever. So it's important that if you're going to use the ... you have to have at least 3 elements listed before it so that you can see the pattern. Okay? So I have at least 3 elements. 4 is nicer because it's easy, it makes it a little easier to see the pattern, and then you can do the ... Okay, so these little arrows are all kind of the important things about set notation. The natural numbers or the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, forever, right? All right, another set is the whole numbers. What are the whole numbers again? You guys remember?
Can you repeat it?
What are the whole numbers?
Isn't there like any negative or positive like integer?
The whole numbers is 0, 1, 2, 3. So it's 0 plus the natural numbers is the whole numbers. Let's do another common set. The integers. What are the integers? So -3, -2, 0, 1, 2, 3. Is that it? Negative whole numbers, positive whole numbers, and 0. No fractions. Okay, so how are we going to write that? So the integers is usually in math written as this fancy z. I think it's something German, I don't remember. Something German or Latin. So how are we going to write that? Negative whole numbers, 0, positive whole numbers. So I can't list all of those out, so I need some ... dots, right? Can somebody help? Good. So the ... means it continues like that forever. So that to the left means it includes all the negative numbers. I'm showing at least 3 elements, so I'm showing a pattern. And then I have a ... there because it continues like that forever as well. Okay? So for each of these sets, I'm adding a little bit more, right? All right, so let's talk about the rational numbers. So what are the rational numbers? When you hear rational, what are you supposed to think? Fraction, good. These are the fractions. So rational is usually written as a fancy Q, is fractions. Okay, but writing it like this isn't very mathy. It's the set of fractions. I think we wrote it like this before. We said it was the set of A over B, and then we did a big line that means such that. The set of A over B such that A and B, are A and B any kind of number, or are they a specific kind of number? A and B are integers, okay? Anything else? Why does B not equal 0? Because the denominator of a fraction can never be 0. All right, we can do a little better. Since we're talking about set notation, the set of A over B such that A and B are elements of the integers and B does not equal 0. All right, so this little symbol means in the set, A and B are in the set of Z. Z was the integers. A and B are integers. That's what it says. So that means are in the set or are elements of the set, are members of the set. A and B are in the set Z. Okay. 5. The real numbers. Does anybody remember what we said the real numbers were? It's written with a fancy R. So the real numbers, so it's more than fractions, right? Can somebody give me an example that's not a fraction? What's a number that cannot be written as a fraction? Pi, really good. Pi, because the fraction doesn't repeat, it cannot be written as, or the decimal does not repeat, it cannot be written as a fraction. What's another example? We did a bunch of them in class. They were on the first test. The radical, right? We did a bunch of adding, subtracting radicals, multiplying, dividing radicals. If you have the square root of 2, that cannot be written as a fraction. So I'm just going to write it as anything that can be written as a decimal. And we said that includes pi, like Meadow said, and the square root of 2, because the square root of 2 cannot be written as a fraction. All right, let's do a definition. A set is said to be well defined so I'm defining well defined if we are able to determine its members. Okay, so let's determine if the following sets are well-defined. So if a set is well-defined, we are able to determine its members. We really only want to deal with well-defined sets. Okay, so example. Determine if the following are well-defined. Okay, so this is number 6. Let's call it C. So I'm just making up a set C. Usually the set is a capital letter, right? The set C equals Y such that Y is a team that has won the Super Bowl. So this slide it up. More? So is this a well-defined set is my question. Can you determine the members? Yes or no? Okay. Have the 49ers won a Super Bowl? Okay, so they're in this set. Have the Buffalo Bills, are the Buffalo Bills in this set? I don't think so either. Okay, are the Bears in this set? Yeah, because the Bears are awesome. Are the Jets in this set? No. I don't know. I think they are. Because they have Eli Manning, right? Oh. Oh, I'm so embarrassing. I just named 6 football teams. I want to get some credit for that. What?
Cowboys.
Nobody forgot the Cowboys. What about
Patriots are definitely in there.
what about oh, there's no football team here. What about huh?
Carolina Panthers. Carolina.
No, I was saying at the school. Okay, what about,
Well, they were defeated here.
I'm trying to come up with other football team examples. What about the football team from UNC Charlotte?
They're trash.
Nope. Okay, what about the swim team from down the street? No. I can tell if a team has won the Super Bowl or not, right? Well, if they're not in the NFL, chances are no. It's not possible, right? So I could name a bunch of teams that are not in the NFL. They have not won the Super Bowl. So then I can look at all of the teams in the NFL and see if they've won or not. So I can determine this easily, right? So yes, this is well defined. I can tell that, and I can determine it easily. Right? Have the Cowboys won a Super Bowl? 73? Okay, let's talk about the set A. A is the set of X such that X is short people. Is that a well-defined set? No? Why not? Exactly. What your definition of a short person is probably depends on a lot of things, right? Jalen, you're on the basketball team, right?
Yeah.
So what you think is short could be completely different than what I think is short, right? So I can't really tell if somebody's in this set or not. Quentin, how tall are you?
6'4".
Yeah, you're tall. Right? But maybe to Shaquille O'Neal, maybe you're not tall. So the thing is that this is very subjective. It's based, I can't definitively state if a person is short or not, right? Because it just depends.
So basically, what you're saying is it'll be well defined if it was like based on the fact, like I don't know, like how you do with the Super Bowl.
Yeah, it's if you look at a possible member and you say, is this thing in there, yes or no, right? If everybody in this room would say yes or no to that answer, then that's probably a well-defined set, right? Awesome, Meadow. Z, so B equals the set Z, such that Z is people less than 5 feet tall. Or 5, whatever, right? Is that a well-defined set? Can I look at people and say, yes, no, yes, no, yes, no? Yeah. Okay, so this is a well-defined set because I can measure it. I can tell if somebody is in this set or not. So this is yes. Okay, so I think that's all that we have time for today. But this section, 2.1, we will finish in class next week on Tuesday, so this will be due on Thursday.